Hi everybody, and a special hello to the guys in Mr. Chanley's geometry class. I miss seeing you guys in person. I hope you're all doing well. We're about to start chapter 10, and I'm going to start making a few videos for each of the lessons we'll be doing. In this chapter, we're only going to be doing lessons 10.1, 10.2, and 10.3. I'll start with a handful of videos, maybe 3 videos today that I'll post for 10.1. Chapter 10 is all about area of polygons, pretty simple stuff, polygons and circles, and quadrilaterals and triangles and things like that. So just area and some perimeter formulas, all formula based. That's the key thing. And in this video, we're going to start off with just the essentials, the basics from lesson 10.1, which most of this you probably have learned before in grammar school or middle school. Most of these formulas are probably familiar to you. So let's just take a second. I would encourage you to write these down on your homework just as a quick handy reference, just a quick little cheat sheet. So let's go through them. Area of a square. So capital A is always going to be area. For a square, S is side. So side squared. Okay. Rectangle area is base times height. Parallelogram, P-gram stands for parallelogram. Area is also base times height, where height is always the perpendicular altitude, nothing on a diagonal. Okay. In a second, I'll draw a picture of each of these so you can get a better visual. Triangle, as you know, area is 1/2 base times height, and that actually comes from the idea of being a triangle could technically always be half of a parallelogram if you think about it. Trapezoid is one to know, and in one of our future videos I'll do one of the trapezoid area problems, one of the more interesting or challenging ones for you. It is 1/2 the sum of the bases, the two parallel sides, okay, which we call base 1 and base 2. So 1/2 the sum of the bases times the height again. So notice there's kind of a pattern here. Base times height, base times height, 1/2 base times height, 1/2 the sum of the bases times height, okay? And then finally we rounded off with the formulas for a rhombus and a kite, and they are the same formula. In a second I'll show you a picture of each of those and kind of why that is. Formula for those, for both of them, is area is 1/2 D1 times D2. In this case, D1 and D2 are the two diagonals, the lengths of the two diagonals. So let me, for each of these, maybe you take a second, write down each of these formulas, make a quick cheat sheet for yourself, and I'll do a quick visual of each of these shapes here. Okay, I don't think you need much explanation, but just in case you do, we'll run through each one. Okay, so for a square, okay, area is side squared. That's obvious. I hope that doesn't need much explanation. Make sure you always label your shapes. So how do you make sure you've labeled a square? 4 congruent sides, 1 right angle locks that in as a square. Give it an S, okay? If that's an S, they're all S's. Area equals side squared, okay? Easy enough, okay? Let's do a rectangle. Okay, so rectangle, again, always label appropriately. Okay, there's a rectangle. Okay, one of the dimensions is the base. Okay, one of the other dimension is the height. Area equals base times height. Okay, from there it's pretty easy to see that that's going to be the same formula for a parallelogram. Okay, but remember with a parallelogram, your height. First, let's make this a parallelogram. Okay, parallelogram. So again, one of the dimensions here is your base, okay? Either sides could be the base, but the height is always going to be the perpendicular, the altitude, okay, between the two sets of parallel lines, okay? So again, parallelogram, area is base times height. I should have written that at the top, parallelogram, okay? Area is base times height. Don't forget height is got to be the altitude, okay? From there, it's pretty easy to see why for a triangle, it's 1/2 base times height. Okay, should know this, of course. Okay, area equals 1/2 base times height. Why is that? Well, take any triangle you can draw. Okay, here's a base. Okay, any side can function as a base, but that just means that your height has to be the perpendicular altitude from the opposite vertex to that base. There's your height. It's pretty, I hope you understand why it has to be that formula, right? Because any triangle could be thought of as 1/2 of a parallelogram. Okay, so there's that. Okay, 1/2 base times height for a triangle. What's up next? Quadrilateral, so trapezoid, okay? This one is a little more interesting, okay? And there'll be a few more of these on the homework because the other stuff's pretty basic, okay? Make sure you learn this formula for a trapezoid, okay? So again, okay, trapezoid defined by quadrilateral with exactly one pair of opposite sides parallel, okay? There's a trapezoid. We call those opposite sides base 1 and base 2. It doesn't matter which one you call 1 and 2, but B1, B2. And then again, I'm sure you're getting the hang of this by now, the height is always the perpendicular altitude between those two bases, okay? And your formula is, and it should kind of make sense, 1/2 the sum of the bases, which is basically the average of the bases or the mid segment of the trapezoid, if you remember that from earlier, times the height. And you can do that formula different ways. You could write it as B1 plus B2 over 2 times H. Obviously, there are different arrangements of that mathematical expression that you can use. Okay, but that's a trapezoid. That one's important. In my next video, we'll do a problem from the homework specifically about a trapezoid. Okay, and then finally, let's look at the formulas for a rhombus and a kite. Okay, so a rhombus, we'll do a rhombus on this side and a kite on this side. Okay, they are the same formula, and let me try to draw a good rhombus here. Okay, not bad. Okay, how do I ensure that that is a rhombus? For congruent sides, right? And let me switch colors for a second. Okay, so it's going to be all about the diagonals. Okay, there's one diagonal in green there. Okay, we're going to call that D1. Okay, and the other diagonal. Okay, remember they're perpendicular. Okay, there's a right angle there. That's one of the properties of a rhombus. We're going to call that D2. Okay, and the formula is area equals 1/2. Sorry, I'm kind of running out of space here. Let's do it better. 1/2 D1 times D2. Half the product of the two diagonals. And don't want to belabor the explanation of that, but if you use kind of a little bit of intuition and common sense, you can see that that comes from the fact that you have 4 triangles here. And if you looked at each one is a half base times height. Well, if you did all 4 of those together, every time you have the base and the base, well, you have a diagonal and the other base and the base, there's the height. So it's basically taking the area of 4 triangles, simplifying all that expression, and you come out with this 1/2 diagonal 1 diagonal 2, 1/2 D1 D2. Okay, same thing goes for a kite. Okay, remember a kite is going to look like this. Pair of adjacent sides is congruent, another pair of adjacent sides is congruent. Okay, the diagonals again bisect not bisect each other, are perpendicular to each other. Okay, one of them bisects. Okay, again you got a 90-degree angle there. Okay, again the green is D1, the red is D2. Same formula, area equals 1/2 D1 times D2. And in my next video we will do a sample of a rhombus and a kite. Okay, hope that helps. Hope you're all staying healthy and happy. Take care. Bye.